Hello everyone, this is Abhinay Adi from ADTA. This is my final project presentation for the course ADTA 5550 Deep Learning with Big Data. And here in this final presentation, in the part 1, we have to select a data set of images or audio files. And I have selected the data set. In this one, a report on audio cats and dogs is something I would want to write. One easy and useful data set that may be used for deep learning is this one. Cats and dogs use their vocalizations to train and test them. There are WAV files for both cat and dog classes in the audio collection. This data set was taken from Kaggle. A 1 or 2 MB data set is respectable size. Overall, it has 271 files, of which 277 are WAV files and one Python file and one CSV file. Here, the dogs have 113 VAV files, which consist of 598 seconds of audio, where the cats have 164 VAV files, which equate to 1323 seconds of audio. And here in this next slide, we can see test cat, test dog, train cat, and train dog are only few of 5 columns in this data set. It has only 114 rows in the total and just null values. And here a spectrogram is used to easily see and analyze the voice frequencies and that are used to discriminate between cats and dogs. Every single VAV file has variable length and 16 kz audio. We can take the dog and cat data frames and change them, such as samples is equals to rows and frequency is equals to column, and an additional target column that indicates which category the row belongs to are added. And in the next slide, the location that you provide in the path variable at the beginning of the notebook is where these data frames are saved as pickle files. These gorgeous models are all drawn from Sclean collections as a starting point. We first run a dummy classifier that consistently predicts cat. Essentially, we are interested in seeing whether models can outperform this. I have provided a link where I have got this data set. And in the next slide, we can see to find, we have to obtain a cipher 10 data set. To find cipher 10 data set in the data sets folder after opening the canvas, and we can find it there. Now next we have to locate and download the 5 data batches and 1 test batch from there. And then in the next step, we have to upload files to a remote instance during a GCP SSH session. Open the GCP in your browser and then started an SSH session by accessing it in the browser. And the next step, we have to start a GCP session in the home directory. And next, we have to open remote instance in GCP and wait for it to load. And in the next one, we have to run the command on the computer prompt to get a list of every item in the directory or folder. And in next slide, we can see, and the next step, we have to click the arrow to see the drop down menu and choose where you want to upload the file to on the remote server. In the next step, we have to select the data file by selecting it on the browse window, then click the open button. The data file is uploaded to the home directory and the distinct VMs and JPBTBK subdirectory is open. That is Jupyter Notebook. And in the next slide, we can see the cipher data set data files were uploaded from the student's local computer to the newly generated subfolder in the distinct instant under the newly established subfolder with the name cipher10 data. In order to determine if the subfolder has been created or not, now close the console and start a new one. And next, type ls to test if the subfolder Jupyter Notebook is there. In the next slide, we can see we have uh, obtained a cipher10 data set. And in the next slide, we can see we have to build and train and test in CNN on cipher10 data set. That's a neural network. And we can see the picture of CNN over here with the input convolutional plus ReLU pooling stages convolution. And this is fully connected network. And in the next slide, we can see the CNN model consists of two fully connected neural networks, two pooling layers and two conventional layers, two convolutional layers. The first convolutional layer with an input of 333 into 32 into 32 will receive the data first. That's a width, height, and depth. The first convolutional layer then processes and resizes the data to 16 into 16 into 32. And next, the output from the first layer will subsequently be applied to the first pooling layer. The data will be processed and resized to 16 into 16 into 64 pixels. And in the next slide, we can see the second layer receives as its input the output of the first pooling layer. The second layer processes and resizes the data to 8 into 8 into 64, which happens with the first layer too. The second layer's output is sent to the second pooling layer. And in the next slide, the second pooling layer will flatten the data into 8 into 8 into 1024. The first fully connected neural network, FC1, is then given the flattened data via ReLU activation. The data will be resized to a resolution of 1024 by 1024 pixel as a result. And in next step, the FC2, which is secondly fully connected neural network, and FC1 is firstly fully connected neural network. The FC2, the fully connected second neural network, receives the output of the first fully connected neural network. It's a dropout layer here to provide the correct output with the 10 knots for each of the 10 classes. A random portion of the outputs were deleted. And in the next slide, we can see the result. The model's accuracy is 70%, as we can see in the image. Here is one. And in the next slide, the report for this, a 50% dropout retention rate is employed to retain the model. In other words, a random elimination will receive the other half of the population. And this model requires minimum of 5,000 steps. The model is the model is trained, and every 100 steps, its correctness is verified. And the next, at the start of 100th step, the accuracy is set at 1%. However, after the 50th step, the model's accuracy gradually decreases to 70%. And then the next slide, we have to compare the convolutional neural networks performance. The photographs in the MINST database are monochrome. The Cipher 10 database has colored graphics. A machine would find it far simpler to process black and white photographs than colored ones. And it contains images that are 28 into 28 pixels in size. The pictures in the other are 32 by 32 pixels in size. Machines would find it simpler to process the images with fewer pixels than those with many pixels. And in the next slide, this, yeah, in the part 5, this is the proposal for improving the convolutional neural network performance. And this we're gonna see in our 5th part. And this I'm gonna continue this in the next video.